Okay, now we want to talk about how to identify minerals. And the first method is by what color they are. Now, normally this is not such a good method because when a mineral gets impurities in it, it alters its color. But in general, all sulfur that you're going to find is the color yellow, and olivine is the color green. Uh, Orthoclase is always the color pink. But let's take quartz, for example. Well, you can have clear quartz, but if you go to a rock shop, you might find red quartz, yellow quartz, green quartz, all different kinds of quartz because of the impurities that are in them. So normally, the actual color of the mineral is not a good way of identifying it. Now, streak is a different story. So what streak is what is the color of the mineral when it is powdered. And so you use a streak plate. So you're going to take your streak plate, take your rock, scratch it on the streak plate, and then look at what the color of the powdered form is. So this actually is a good way of doing it. And there's all sorts of different kinds of streaks. Now you would not need to know the different streaks for different minerals. So you're going to do that in lab. But don't worry about that on the lecture exam. Just know the definition of what streak is. Okay, similarly, you should know what luster is. So the definition of luster is how it reflects light. And there's only two kinds of luster that you need to know for the exam. And so that's going to be, is it a metallic luster or is it a non-metallic luster? So if it's a metallic luster, it's shiny like a mirror. And if it's not, it's not. So an example of a shiny luster, a metallic luster, would be galena, lead. So lead. So lead is going to be very shiny. Okay, on the other hand, quartz, well, it's shiny, but it's not shiny like a mirror. And so quartz is not, it's going to be a non-metallic luster. Okay, crystal form. So what is the shape of the crystals for that particular mineral? And I said that you should know salt. So halite is a cube. Another good one to know is quartz. So quartz makes a hexagon. So if you look at the hexagonal one, so an example of that would be quartz crystals. Another one is going to be hardness. So you should know the softest mineral there is, and you should know the hardest mineral that there is. So the softest mineral, the one that resists scratching the most, is going to be diamond, and then the softest one is going to be talc. And then you see that all of the other minerals fall either between diamond or talc. Okay, then you have tenacity, which is going to be how does the mineral respond when you apply a force to it. Remember, a force is a push or a pull. So if you take that mineral and you start to apply a force to it, what's it going to do? Well, it could behave elastically. An example of that's going to be mica. So mica was the one that bent real easy. Okay, another one is it could stretch. So whenever you pull on it, it's going to pull out like taffy. And so an example of that would be copper. And so the reason for that, or the reason why that's important, is you can take copper and you can turn it into wires. Okay, then other minerals, when you apply a force to them, they're going to break. That's going to be brittle. And so if it doesn't break along faces, we say that it's going to fracture. An example of that is quartz. You should know the word conchoidal. So conchoidal means that it fractures along these nice curves. If you've ever taken a piece of glass and you break it, you notice it doesn't make nice sharp, or it doesn't make edges that are nice and smooth. They have these kind of curvy faces to them, and that's conchoidal fracture. If it does break along faces, then that's going to be called cleavage. So you should know all of these different words for the exam. So here's the different kinds of cleavage. And so you're not going to need to know that for the exam. But those are the different kinds of cleavage. You should know what cleavage is, but you won't need to know the specific kinds of cleavage. Okay, and then this thing here about how to tell the difference between crystal shape and cleavage, let's not worry about that. Okay, another way of identifying minerals is specific gravity. So we've already talked about density. So density was given by the letter rho, and it was the mass of an object divided by its volume. So if you've got a rock, one way of finding its density would be to take the rock and put it on a scale, and so that's going to give you its mass. Okay, then take the rock and you put it into a glass of water, and you observe how much does the water rise. And so you measure that amount of water that rose, and that's going to be the volume, and then you divide the two, and then that would be the density of the rock. Well, this is not really the way that most geologists think about density. Instead, they talk about specific gravity, which is the density of the mineral divided by 1 gram per cubic centimeter. Now, what happens, let's say that your density is 10 grams per cubic centimeter, and then you divide it by 1 gram per cubic centimeter. Well, what do you get? Well, 10 divided by 1 is still 10. So it's still the same number, but it got rid of the units. So this is it's much easier, because instead of having to tack the unit on the end of it, all you got to do is say the number. And so if something has a specific gravity of 5, then that means it has a density of 5 times the density of water. Okay? And then some other properties. Let's not worry about the electrical properties of minerals. You should know that the mineral that attracts a magnet is magnetite. Okay? You should know that the mineral that is salty is halite. You should know that the mineral that reacts with acid is calcite. Make sure to know that for the exam. Okay, let's take a break. And when we come back, we're going to talk about the abundance of the elements.